Hello. Hello students, a very warm welcome to JEE English by Unacademy, India's leading and largest JEE test preparation platform. And students, you are on JEE English, which is the nation's first channel where you get all your lectures for your JEE preparation from basics until advanced. And today guys, we are going to discuss a very interesting topic. It's going to be about screw gauge. It's a very small concept, but there were quite a few number of questions in your JEE Advanced and JEE Mains. And they're pretty easy if you understand the concept. Stay until the end so that you can understand everything, and also call your friends on board. Share this video on the social media, share this video on on your WhatsApp, like Telegram, etc., on your Facebook, so that you can have more people on board. And guys, that being said, do not forget to click on that like button and subscribe button to get awesome notifications on the lectures that is being conducted by the lectures on JEE English. And students who know me well and good, if not, I'm Murlidharan Gopalakrishnan. I completed my MS in Electrical Engineering from University of Colorado Boulder, one of the top ranking American university in electrical engineering, and I'm also an IITian who completed BTech from IIT Guwahati. I have 4+ years of experience preparing students for JEE and other competitive exams. And I filed 25 patent applications in India and abroad. And students, today's topic is going to be super interesting. Stay tuned, it's super easy. Like in Vernier calipers, we have a little bit of complications here and there. If you haven't completed Vernier calipers, also complete this after that lecture, because that is also an important one. And that being said, students, this Sunday at 6 p.m. we are going to host a session on what to do after your JEE Mains result. In this, we'll be discussing all about your branch selection and what should you do if you are planning for something else, or if you're preparing for JEE Advanced. What should be the strategy, and how should you plan accordingly? There are many unsaid things about your admissions and also your JEE Advanced preparation. We'll discuss all about it at 6 p.m. sharp, students. So stay tuned and do not miss out this lecture. And that being said, guys, actually a very hearty congratulations. I hope many of you must have got your results with flying color. If not, you're going to get your results with flying color. And students, get on to our Telegram channel. First of all, you need to download the Telegram app. So what is this channel? This is like a Telegram channel of JEE English. So we have awesome lecturers on this like JEE English channel who come every day to deliver lectures online for your JEE preparation. And I come every day at 7:30 p.m. From Monday to Friday, where I come up with your lectures for your target 2021 and target 2022. So target 2022 is conducted on Monday and alternative days, and whereas target 2021 is conducted on Tuesday and alternate days. That is going to be Tuesday and Thursday, Tuesday and Wednesday, Tuesday and Thursday. So stay tuned, and also get on to this channel to get all the updates on the special classes or anything that we are conducting on even Unacademy learning app or on YouTube, any special sessions, any target oriented program. You can get the update. All you need to do is you need to click on that link that is available in the description box below. And students, if not, you can just type in JEE English. We are already on Telegram channel. And that being said, I didn't get your question. And that being said, students, this Sunday from 11 a.m. to 2 p.m. we are going to conduct a one-shot lecture on projectile motion, where we are going to discuss more problems on projectile motion, and as well as I'll take you through the concepts, every single concept that is necessary for your JEE Advanced and JEE Mains. So it's going to be it's actually, projectile motion is super easy, guys, if you understand the basics and how everything works, be it on an inclined plane or be it on a flat earth surface or be it from a height. We'll discuss all the scenarios. It is super easy. So do not forget to attend this session from 11 a.m. to 2 p.m. on Unacademy learning app, guys. So you need to come on to the Unacademy learning app to attend it. It's a free of cost special class. And we also conducted a special class on electrical measuring instruments or electrical instrumentation on 1st of September. And the awesome thing about this electrical measuring instruments, it's quite easy, guys. All you need to do is you need to attend the lecture and make sure you are thorough with all the concepts, be it especially 2021 aspirants and also JEE Advanced aspirants. Do not miss it out. We discussed like JEE Advanced problems and JEE Mains problem. We discussed pretty much every concept, be it ammeter, voltmeter, a meter bridge, or like potentiometer, and how do you use potentiometer, etc., etc. Every concept was discussed in details, and we took it from the basics, so you don't even need a prerequisite. Cover this topic. It's pretty much our topic in your JEE Mains and JEE Advanced, and also in JEE Advanced you get it. So we conducted on 1st of September on the Unacademy learning app. Hi Kishan, hi Kishan, hi. So do not forget to attend this class. So it's pretty easy, guys. All you need to do is you need to know the basics, and you'll understand that it's also very practical. And that being said, students, to attend these special classes, you need to download Unacademy learning app. First of all, you will type in Unacademy on your Google Play Store and App Store, and your first result is going to be Unacademy learning app. You'll click onto this link and click on this install button, so that you will get all the live updates and timely notifications on anything that is being conducted by me or any lecturer on JEE English or any lecture that you're following up. It is pretty comfortable to have the app, and you can get timely updates on everything, and you can attend your classes from anywhere. Even if you're a plus student, make sure you're having this Unacademy learning app over the web version. And students, that being said, we have an awesome platform, or like a program for your JEE preparation. And guys, it comes with everything that you need for your JEE preparation, be it live quizzes or be it test series or be it the top-notch educators across the nation. We have everything for you. It's going to be a structured program. It comes with everything that you need for your JEE preparation, be it for JEE Mains or JEE Advanced. And guys, that being said, what all you get in it, you get access to live quizzes, live test series, a very structured program where you get to attend all the lectures on a daily basis, and it's going to be scheduled according to however you want. And you can learn from your favorite educator, and you can also learn from our top-notch educators, and we have popular authors and educators on this platform. And guys, it's the state-of-the-art tech which you need for your JEE preparation. It comes with everything that you would need as an experience for your JEE exam. So it's an awesome tool for your JEE preparation. All you need to do is you need to click onto that extension bar and choose this this icon over here, and then you will choose your goal as IIT JEE, and that is all you need to do, guys. And then post that be sure about your goal and have your dream in your mind, be motivated, never get discouraged. I mean, the tests are meant to be like that, and it will come with practice, guys, and that's why you're purchasing this platform, and then you will get the subscription. And that being said, it's not very expensive, guys. It's going to only cost you 2,100 per month for a 24-month subscription after you apply Murli Live coupon. Do not forget to apply the Murli Live coupon, and you're going to get access to daily interactive classes and many more things. And this is for a 24-month subscription, and we have everything that you need. So you can also avail EMI based options. And do not forget to apply the coupon. This is going to get you the best price, and it's only hardly 2,100 per month, which is quite economical, guys, which is going to be the cost of your travel. And that being said, then you can choose your payment mode, and you also have EMI, no cost EMI based option, so you don't have to pay any interest, etc. And that being said, students, do check it out. And if you are in long term, or if you are a dropout, you can also check out our 12-month program. So a 24-month program is well suited for those students who have 2 years, 1.5 years for the JEE preparation. And if you have let's say if you're in 11th class, or if you're in 9th class or 10th class, or even if you're in 12th class and planning to pursue this IIT JEE dream, then get onto the subscription. It's only going to cost you 2,100 per month. And guys, if you're in a long term or dropout, you may want to choose the 12-month subscription. Since you have 1 year, we have programs accordingly. We have 6,000 plus materials for your JEE preparation. Hi Rohan, very good evening. And we provide you everything that you need for your JEE preparation, be it you are in a 12-month program or a 24-month program. But 12-month program is going to be fast-paced, and it is typically meant for students who are in long-term or dropout, and they have dedicated 1 year. Anyway, it's a 2-year long journey, so do not forget to avail the 24-month subscription, especially if you are in 11th class or 9th class or 10th class. And if you're a long term or dropout, this is going to only cost you hardly 2,900. I mean, like, it's going to be only 2,888. You have to apply the Murli live coupon. Do not forget to apply the Murli live coupon, and you will get access to anywhere around 6,000 plus materials and 1,500 plus active courseworks going on, and also popular authors like DC Pandya sir, etc. on this single platform. And you understand the value of the platform and the kind of the things that we provide you for your JEE preparation. It's a quality education, guys. And also do not forget to share this video and click a like button and subscribe button on this on this channel, so that you can get timely updates on what is happening on JEE English. It's a free of cost initiative and academy where you get all your lectures from your basics until your advanced for free of cost, students. And Rohan, that is no. Not really. You can understand. So Rohan has a question. Sir, can we clear JEE Mains only by doing previous year question papers? Of course, no, students. That is a myth. See, you get to understand the model, you get to understand the trickiness. For an example, right now, if you're a JEE Advanced aspirant, you should be solving as many JEE Advanced papers as possible, because you'll get to understand the model, but that does not mean they're going to ask you the same kind of model problems or the same kind of concepts. No, they cover different concepts in different papers. No, previous year papers all alone is not going to help you. It is going to be useful. You need to attend lectures regularly. You need to attend more and more test series, more and more quizzes. You need to get accustomed to it, guys. So you get all your lectures on JEE English for free of cost. And do share this channel, do click a like on this video, and also share this video on your social media. Ask your friends to come on board and be on time, guys. And also do not maintain any backlogs on your subjects. This target 2021 program and 2022 program has just started, so do not maintain any backlog. Even if you're on an academic subscription, do not hesitate to give those tests. They are the key, guys. This is all about learning and conceptual learning. You get that, but what about your test series? You get it on your Unacademy subscription platform. So make use of it, and make sure you are attending as many tests as possible. And also you must be learning the subject. And that being said, students, an experiment is a question which you pose to the nature, and a measurement is the recording of the nature's answer. And today we are going to measure the nature's answer better than the last session with more accuracy. Let's get into it and understand. So we know about Vernier calipers. Yes, Vernier calipers helps us conduct better research, design better structures for our engineered products, etc. It helps you conduct better quality check, but there is a disadvantage of Vernier calipers. What is the disadvantage? You can't really measure thickness. I mean, like a thickness of like some material, of thin metal sheet, or like the electrical wiring that you have, because the least count is fine. It's 0.1 mm, but it is not designed in such a way. And even that being said, the accuracy of Vernier calipers is not so much, and you cannot really measure many things, like many tiny things. You need something known as screw gauge, students. And screw gauge is an awesome measuring instrument, and it is going to come up with everything that you need to measure thickness of thin sheets and thin metal sheets, or be it any thin sheets or a thin glass slab or thin wires. How do you measure those thicknesses? As I told you in the last class, everything matters, guys. When you're designing something, let's say you're designing a car, the thickness of that glass matters. If you're exceeding that thickness, or if you're designing something thinner, that is actually going to cause a lot of problems. One is in terms of fitting, the other is in terms of your stability. Okay, if you're designing something way too huge, that is not going to fit in. If you're designing something way too thin, it can be of lesser like quality, etc. There are many other things. Thinness does not mean necessarily lesser quality, but it may not fit properly. There are many other things, many things where you need to assess the thickness up to 0.01 mm, and that is where screw gauge comes into the play. It helps you do everything with more precision and with like a more comfortable manner than a Vernier calipers. It's not just about precision, it's also about the design. Get this point, students. And screw gauge is also called micrometer. Why do we call screw gauge as micrometer? I don't know yet, KKS. I don't know. I'm too waiting eagerly, just like you, for your JEE Mains result. I'm excited about it. I'm sure pretty much that pretty much of you must be cracking this exam with flying colors. I'm hoping to see that. And students, do you know why do we call screw gauge as micrometer? not because it can measure something up to the micrometer range, but it comes from the past, language based thing. It's a colloquial thing. So back in the days there was no concept of meter or micro. There was not concept of a meter. Of course there was nothing like a micrometer. So back in the days it was about the terming things. So initially Vernier calipers was invented, and then screw gauge was invented, and the screw gauge was able to measure things with more and more precision than Vernier calipers in the 17th century. Back then there was no concept of micrometer. People used to call this micrometer screw gauge or micrometer because micron means small, metron means measure. So you can measure small things, that hence the name screw gauge is also called as micrometer. Screw gauge is a modern term. You'll understand why do we call it screw gauge. There are specific reasons for that. Try to understand everything that we discuss in this class. It's an easy concept. It's easier than Vernier calipers, guys. It's literally easier than the Vernier calipers. I'm betting on this thing that it's easier than Vernier calipers, but you need to stay attentive. And there is nothing in this. There are also terminologies that will be mixed up in your exam. So try to understand everything as much as possible. Take down the notes, share the video, click on that like button. And that being said, this is like a small simulation of calculating some thickness of a pencil, etc., where your Vernier calipers can do this job, but not with the sheer accuracy that your screw gauge can do. So what you typically do over here is, if you notice that this friction screw, you will just keep rotating that, and there is this known as measuring rods. These things are known as measuring rods. We'll discuss the different names for that, and this is fine. This is like a very modern thing. Locking lever would not be there. Instead there would be a ratchet. So we would be using ratchet in our labs. So you would have this measuring rods. You would put your this, let's say I have to measure this stylus thickness or something, the diameter. In fact, this totally cylindrical. So if I have to measure this diameter, I'll put this between the measuring rods. I'll screw it initially anti-clockwise and then screw it clockwise, and keep rotating the friction screw or ratchet to ensure that it is firmly fixed. And it will create a little bit of that noise to tell you that it has been fixed properly. And consider expanding. We'll discuss about it later, guys. Of course, you can come on to my Unacademy Learning App classes. Maybe there I can take up your questions for education. And also maybe when we are discussing similar topics, it would be also useful for students. Today we have to cover screw gauge, and I'm assuming there are some advanced aspirants as well who haven't covered this topic. Guys, this topic is also asked in advance, and the questions are so easy. I mean, this is one of those topics where you get that easy bag of score. Those are like cakewalks, so you should get those sugar candies, okay? And it does not even take much time. And that being said, so you will keep on screwing it using your thimble. Yeah, we have a JEE English channel. I do not have a personal channel. So that being said, what you need to do, you need to keep on screwing it, and then then beyond a point of time it will get locked, just like how you're seeing this pencil, and then you will read the reading. So we'll come to that part. First of all, let's understand what all it consists of. So there are two ways of calling things. Okay, first of all, let's understand the general terminology. So these things are also called measuring rods, but the internal mechanism is something known as like a screw. Basically a screw, okay, a very well measured screw, and this is a frame. That is fine. The frame is not of any use to us, but there is this stud where you balance or you keep initially. So you are going to stick your material to the stud, or you're going to let's say I have a thin wire, something like this. Then what I'm going to do is first of all place it on the stud, and now screw it in the clockwise direction and make sure it is tight. I'll ensure that using my ratchet, and I have something known as thimble, and this thimble is what I will use to rotate. And there are two scales, just like how you add in your Vernier calipers. One is going to be a pitch scale or the main scale. So note down this terminology, students. Okay, there are two ways to call this scale. Okay, in your exam they can give about many things. So that is the reason I'm discussing also the terminologies. One is going to be a pith scale. I've seen some JEE advanced problems. JEE advanced problems are pretty straightforward, but JEE mains problems, you often see that they'll call that pith scale, and they'll talk about why or in the other one they'll call it as a main scale, and this is known as circular scale. Okay, circular scale. There you had Vernier scale. Here it is circular scale. The mechanism is pretty easy. So now think about it. When I'm rotating it, along with I'm actually rotating it in a very measured way. Okay, what I'm talking about is that this thing that you're rotating. So this is the one that is rotatable, right? You're using either the friction screw or the ratchet or the thimble to rotate it. But if you've noticed it, this thing that you're rotating is moving in a measured way. Like every rotation can be measured. That is what we have done. We have exactly calibrated this circular scale. This is the circular scale, right? We have exactly calibrated that circular scale, and this circular scale, once it moves, it will also create some it will create a displacement horizontally, which is going to be equal to the main scale. We'll understand that point. And that being said, do understand that the circular scale is well calibrated. It's an easy mechanism. Think about it. You have an object and you're screwing things. Each rotation, a 360-degree rotation or 180-degree rotation, is a measured rotation. Okay, and this rotation, even moving clockwise or anti-clockwise way, is also a measured linear rotation. Think about your screw. Think about that screw as something which is not having diminishing screws, but a very very much less of varying screw. Then it is going to move even in the linear direction. If you have those screws in a very measured way, they are going to move even in the linear direction in a measured way. That is the concept behind screw gauge. That is all it is. So it consists of two scale. One is known as main scale or pith scale, and you also call it as pith scale. This is the bigger one. Whenever they are talking in the question about the main scale or pith scale, it's the same thing. We'll understand why we call that pith scale, and there is also other names for that small scale. Okay, the circular scale as a name. Okay, it is known as head scale. Okay, it is known as head scale. There will be measurements on this. There will be 100 divisions or 50 divisions depending upon the type of the screw gauge. Okay, and there are other ways to also call this stud. Instead of stud, you may call it as anvil, and instead of measuring rod, or instead of that screw, you'll call it as spindle. And this will be generally called a sleeve, not barrel much, but sleeve is the general term used. Thimble will be thimble, or they'll call it as a circular scale or thimble reading. Okay, thimble is the circular part, so thimble reading. Ratchet is going to be ratchet or friction screw, etc. These kind of names will be given to it. So do remember it. What did I say? I said a couple of things. One is your main scale can be called as pith scale or sleeve, or that linear scale, etc. These kind of names, these are used in your JEE Advanced as well. Okay, these are used in your JEE Advanced as well. I mean, they won't use sleeve, etc. But instead of they do not explicitly mention it as main scale. They'll mention it as linear scale, etc. Because this is a circular scale. This works on circular rotation principle, where you have calibrated it to a very good extent. And you see this line over here. This line is known as baseline or reference line. There are two ways you call this line. Baseline. So these are just terminologies, like how you learn, how you learn pretty much any terminology. It's the same thing. But these terminologies are way to address them. Okay, so you need to remember these terminologies as well, so that you don't get confused in your exam. Okay, and there is also spindle, lock nuts. There are different mechanisms for screw gauge, but in our case, we are only worried about how it works. So in this case, if you are noticing, there is a thin wire, and this thin wire is attached between a screw gauge. I'm showing a very different pictures. The reason is each picture is explaining something different. So be cautious and take down your notes while we are discussing it. Okay, that being said, if you have noticed, there is a screwing mechanism. So you saw that initially it was plain in our case, but actually there is a screw, okay, inside it. So this screw, right, if you ever notice a screw, if you move it once inside, it is going to move a specific distance, and that distance is called as pitch. So let's say I rotate it such that one of my screws disappear. Think about pushing that screw into a wall. Then if you, these are known as threads, right? You know that, I guess. So these are known as threads. Okay, this small things over here are known as screw threads or screw gauge threads. In this case, it's going to be screw gauge threads. So whenever you're going to screw that screw using like your screwdriver or something, and you'll notice that with one complete rotation, one thread will disappear. Okay, and there will be, depending upon the type of screw, there will be a linear movement, a defined, specified linear movement, and that is also very important for many of your like your designs. And we call the distance between these two threads as pitch. So that is the reason this is also called pitch scale. So we call this distance between two threads as pitch. And what is this distance going to be? Unit measurement on your main scale or unit measurement on your pitch scale. Okay, unit measurement on your main scale or a unit measurement on your in your basically, but only the unit measurement of main scale. Okay, not circular scale is not concerned over here. Okay, we'll talk about it. So what happens is it'll once you measure two distances between two threads, you will come to know that it has a unit measurement. If you try to screw it once such that one thread comes out or one thread disappears, so in screw gauge you'll observe that one thread will disappear over here or one thread will come out from here. Then you'll observe that linear scale has moved. Linear scale is what? This main scale has moved by unit measurement, unit least count on main scale, not the least count of the screw gauge. Okay, and how do you achieve that? You completely rotate it by 360 degrees. So with one rotation of the circular scale. So this is a very awesome mechanism where you are just rotating that that circular scale like a screw, and you notice that with one rotation, one measurement or the one unit measurement on the main scale moves. So this distance between two threads is known as pitch, but pitch is actually where you are rotating it once, you're rotating it once, or one complete rotation of that circular scale gives you pitch. You need to understand pitch. You need to know what is pitch. They can call it distance between two threads or one complete rotation. But general thing you'll see in your exams is one complete rotation. Okay, but anyway, do remember it. How are these addressed? And that being said, one pitch, as I told you, will give you that one complete rotation. What is pitch? One complete rotation, right? One complete 360 degrees rotation is going to give you one main scale division, one displacement in one main scale division. One complete rotation is going to give you, this circular scale will move by one, one main scale division with one pitch or one complete rotation. Very important, students will understand why. You have rotated that circular scale 360 degrees once, and that measurement on that circular scale is also moving, if you have noticed it. So what is going to be a least count? Your least count is not actually something on your your main scale. The main scale's least count is different from the least count of screw gauge. Screw gauge's least count is going to be pitch by number of circular scale division. Basically, pitch is nothing but one main scale division. You achieve it by one complete rotation or by measuring the distance between two threads. Okay, and you understood the use case of screw gauge. One is its precision and the other one is a thin wire like this. Can you actually measure a thin wire like this on your Vernier calipers? Of course not. It's going to be really tough. So that being said, least count is nothing but pitch by number of circular divisions. That is all it is. And guys, you had a JEE Mains and JEE Advanced question on this. Okay, so this was your JEE Mains question. The least count of a main scale of a screw gauge. So remember what I told you, and you can solve it, guys. If you're watching it, get started on it. Okay, least count of a main scale of screw gauge is given to you as 1 mm, right? and the number of divisions on its circular scale, so that you can measure the minimum number of divisions. Okay, there can be any number of divisions, lesser than that or more than that also. I mean, more than that can also measure the this 5 micrometer diameter of wire. And guys, what is this question? Just on least count, that's all. Is that question that easy? Yes, that is that easy. Right, what do they mean by least count of the main scale of screw gauge? That means the value of pitch, or 1 MSD. That is what is given to you, which is nothing but pitch, is 1 mm. Right, this is what? This is just the pitch. Pitch is nothing but the least count on your main scale. Okay, and you have to measure something known as 5 micrometer diameter by the minimum number of divisions. Okay, so you know how to do this. This is nothing but pitch divided by CSD, number of CSDs, not just CSDs, total CSDs. It's going to give you least count. And the value of pitch, 1 mm, divided by number of divisions. I'm just writing it down as number of circular divisions, circular scale divisions, is equal to how much? 5 micrometer. This 10 to the power minus 3, this 10 to the power minus 6. I'm just cancelling it out and writing it down as 1000, 10 to the power 3, 10 to the power minus 6, 10 to the power minus 3, and 5. It's going to be how much? Just 200. Right, that is all it is. You need number of divisions as just 200, like a 1 minute problem, and this carried 4 marks. That too in 2019 mains, guys. Okay, pretty easy concept, and that is all you had to do, and you would have scored 4 marks. Let's get into so spindle. Remember the spindle. Spindle is advancing, but means what? The screw is advancing, right? So the thimble of a screw gauge has 50 divisions. What is thimble? Thimble is nothing but your circular scale. Right here, this is known as circular scale. Just terminologies, guys. And spindle means main scale advances with 1 mm. Okay, sorry, there's not one main scale division actually, it is 2 revolutions, right? Anyway, spindle is nothing but 2 main scale divisions in this case, okay? So 1 mm on main scale. That is what spindle means. And for how many revolutions? 2 revolutions. Then they are asking you what is the least count of your, like screw gauge. Quite easy. Get started on it, students. So the thing is, that spindle advances 1 mm on 2 revolutions. Then what is the value of your pitch? What is the least count of your main scale? That is going to be 1 mm divided by 2, because on 2 revolutions you achieve that 1 mm. That means you can actually measure 0.5 mm on your main scale. And that being said, how many divisions? That's your circular scale, that is thimble as 50 divisions, right? 50 divisions is what it has. Least count is equal to pitch divided by number of circular scale division. Is that what it is? Yes, that is what it is. How much is it? 1 divided by 2 into 50. This is 50. That is it. That is it. That's it. 0.01 mm. That's it. Simple. So your least count should have been don't miss out this 2 revolutions. Okay. This is basically 0.01 mm. 10 to the power minus 2 mm. Okay. That is it, guys. That is it, right? Quite simple. And you saw the JEE mains problem was even simpler than this. Alright, let's move on to the next problem. This is the interesting one. So we are almost going through all different kind of terminologies. So notice here what has been told to you. A screw gauge has 500 scale on its head scale. What is head scale? Head scale is nothing but circular scale. What is head scale? This is nothing but circular scale. Right? So it has 500 scale, that means it has 500 divisions, and the head moves 5 mm when rotated 10 times. Then what is the value of pitch? Pitch is equal to 5 mm divided by 10. That is what it is. So it should be 0.5 mm. Right? That's it. That is all we have to do, guys. Students, it's a very conceptual and an easy one. That is it, it is? Yes, that is what it is. So now they are asking you, this is the part 2 of the problem, and the same problem, right? So the screw gauge has 500 scale on its head scale, and the head scale moves 5 mm and rotated 10 times. What is the least count of the screw gauge? We just found the pitch. How much was pitch? 0.5 mm. And what should be the least count? Least count is nothing but pitch divided by number of circular scale divisions, and that is 500. Generally, if you're finding it very confusing, because they're going to move things by decimals only in your question, so make sure you're writing it down. If this sounds confusing, you can note it down in terms of 10 to the power minus. So that is what I do generally when I find something very confusing. So I take it in the form of 10 to the power. This is going to give you 10 to the power minus 2. It's already 10 to the power minus 1. It should be 10 to the power minus 3 mm. Okay, but you're not going to write it down that way. So least count is how much? Least count is 10 to the power minus 3 mm. Pretty straightforward concept, students. That is 0.001 mm actually. You get it in many of your competitive exams because this is a very practical experimental subject, right? 0.001 mm. Right? So, a very interesting question. The least count of the screw gauge. They can say the least count of the screw gauge or the accuracy of the screw gauge can be increased by increasing the number of divisions on circular scale, or by increasing the number of divisions on the main scale, or by increasing the pitch of a screw gauge, or all of the above. What do you think should be the answer? It's a pretty straightforward. Not actually. Least count of the screw gauge can be decreased. If you're decreasing the least count, that means you're increasing the accuracy. If you're going to increase the value of pitch, distance between one main scale, that means you're probably increasing the main scale reading, which means pitch value is increasing, and which is going to not deliver so much accuracy. Okay, so two things are true in this. If you are going to increase the number of divisions on the circular scale, your accuracy is going to increase. If the 360 degrees rotation is in 50 divisions, that is less accurate than the 360 degrees in. So one rotation is what we are talking about when we are talking about number of divisions on circular scale. If 360 degrees in, let's say, 50 divisions is less accurate, this thing is less accurate. If it had 100 divisions, 100 divisions is more accurate, right? This is more accurate, right? You understood the concept, right? You're calibrating it, guys. You're calibrating it. You increase the accuracy, and if you increase the number of divisions on the main scale, so it depends how you're doing it. If you're increasing the number of divisions on the same length, yes, your accuracy is going to increase. If you increase the pitch, your accuracy is going to decrease. Your least count as increased. Got it? Alright, let's move on to the next question then. It's a conceptual question, right? If the pitch of the screw is half a mm, the number of divisions on the head scale, or the head scale divisions. What is head scale? Circular scale. Right? This is nothing but circular scale. Try and get accustomed to different terminologies in this chapter especially. I haven't seen anything like that in your Vernier scale, Vernier calipers, but in screw gauge you get different terminologies in your exam. Reference line is what your baseline is called sometimes. That too in JEE Advanced that happened. Okay, so the value of the pitch is half mm. The number of divisions is 100. What is your least count? Your least count is what? Your least count is pitch by number of circular scale division. Make sure you're completing everything within this session on screw gauge, okay? Probably you'd have to practice a little bit more, but not much. This should be good enough. So it's 1 by 200. How much is that? 0.5 or 5 into 10 to the power minus 3. Is that what it is? 5 into 10 to the power minus 3 and 5 into 10 to the power minus 3. This is the 5 into 10 to the power minus 3. Right? 1 by 200. 1 by 200 is what? You keep 1000 on the top. You are going to get 5 into 10 to the power minus 3 mm. This is all in mm, right? This is also in mm. This is also in mm. This is also in mm. Which corresponds to 5 into 10 to the power minus 3 over there. Okay. That's going to be 0. Not 0.05, 0.0005. 3 decimals to the left. Okay, let's move on to how do you read measurements on screw gauge. Screw gauge is pretty straightforward, students. It does not have any new thing like rest of the things. So I hope you're able to see the picture over here. Think about it, take a couple of minutes and think about it. What should be the reading? It is, I told you that circular scale is a way of calibrating things. Okay, one little rotation is calibrated. So what is this? This is your main scale. Alright, let me give you a couple of informations on this. So everything on this is in mm. This is your main scale. Everything on this is in mm, and this each division, you know how much it is. Okay, and this one has 50 divisions. If you have noticed it, it goes from 0 to 45, so only 50 divisions. Right. So this is your circular scale reading, and not division. Yeah, it's also that number circular scale division, but this is your circular scale reading. Okay, and you'll soon understand that this is a reading, and this is your main scale reading. Okay, so first of all, you need to understand, you know, on the main scale, you see, right? You see this edge. I told you one rotation is creating some linear movement. How many rotations has happened such that this linear movement has happened? We are not worried about it. We are all worried about it is within that 50 divisions. Okay, probably, you know, in this case, it started from 0 and went till 3.5, I guess. This is, so understand, this is 3.5. This should be 2.5. This should be 3.5. Okay, 3.5 means 700 rotations has happened. 7 rotations have happened. We'll understand how, but that is not the point. So if you're seeing something like this, how much is this value? This is 3.5. Even figures will be given to your JEE advanced problem only had a picture. Okay, so understand it. So this is 1, this is 1.5, this is 2.5, this is 3, and this is 3.5. So your main scale reading is how much? 3.5 mm. And what is the least count or the main scale division value? What is the value of pitch? 0.5 mm. Okay, 0.5 mm. Okay, I'm telling you, maybe the pitch can be different. Okay, pitch can be different. It can be also 1 mm, but in this case it is 0.5 mm. Okay, and you need to first of all understand that this each small rotation over here, every single degree that is rotating here is basically, you know, like a least count. On circular scale, that each rotation is nothing but, you know, a least count. Okay, first of all, we need to find out least count. How do you find out least count? Pitch. I told you what is the pitch divided by number of divisions on your circular scale. on the circular scale. Okay, how much is the value of your pitch? 0.5 mm. And what about the number of rotations? Sorry, number of divisions, not the number of rotations, number of divisions. That is going to be 50. How much does this give you? 10 to the power minus 2. Is that what it is? 10 to the power minus 1, again 10 to the power minus 1. So it's basically some 10 to the power minus 2 mm, or 0.01 mm. Okay, this is your least count. So this instrument over here has a least count of 10 to the power minus 2 mm, which is equal to 0.01 mm. Right? Let's move on and understand now. Now, which is the coinciding division? So now it is, I intentionally took like a larger reading. How much is this reading? This has 50 divisions, is that what I told you? This is 45, this is 46, this is 47, and this is going to be 48. Okay. How much is this? This is 46, this is 47, and how much is this? 48. What is the division that is coinciding with the main scale is what you have to see. What is the division that is coinciding with the main scale baseline, main scale reference line? It can be called in multiple ways. That 48 division is coinciding. Right? The 48th division is coinciding. So it has moved in the linear way. So the 48th, part of the rotation out of the 50 has moved, 48th times the least count on main scale. So a circular scale is basically giving you a reading of how much? What is a circular scale reading? It's going to be least count into that circular scale division. In our case, we know the least count is 0.01. We just derived it, right? 10 to the power minus 2 into, what is that circular scale division? 48. How much is it? Circular scale reading? 0.48. It's an mm. Be cautious of the units, especially in your exams. This is your circular scale reading. Okay. So what should be your total reading? Your total reading should be main scale reading, just like in your Vernier calipers, main scale reading plus. So there it was different technique, right? You measured that small distance length and etc. Here it is straightforward. It's straightforward, just rotating it, more accurate. Okay. So your what is your measurement? Your measurement or your reading is how much? Main scale reading plus circular scale reading or head scale reading. What is your main scale reading? Main scale reading was 3.5 mm. And what about your circular scale reading? 0.48 mm. That gives you an accurate value of 0.98 mm. Okay, this can also be called as reading. You use this in your labs, even in your engineering, guys. So try to understand this concept as clearly as possible. Okay. So a circular scale reading was what? Coinciding, circular scale division with main scale. Okay. Coinciding, baseline. Assuming it started from 0, it has rotated that 48 part of that one rotation, like 50 by 48 by 50th part of that one rotation. Some nth part of that rotation is what is being completed. Okay, instead of that full rotation, if it has rotated once fully, it has moved one pitch. Okay, one least count on main scale. But what it has actually done is it has only moved 48 out of that 50 of that main scale reading. In this case, it depends, like 98 out of 100 or 96 out of 100, whatever it is. Okay, but the way we do it is in a very simple manner. We will multiply least count with that coinciding circular scale division with the main scale baseline or reference line. There are two ways to call it. One is going to be baseline or the reference line. See, this is the baseline, right? That is what we are analyzing. This line over here. Okay, pretty straightforward, easier than your Vernier calipers, and it's also called as reference line. Yes, this is also for JEE Mains and JEE Advanced. Yes, and there are many questions in your JEE Advanced on this topic. We are going to discuss that. Yes. So we just discussed it. Your measurement is nothing but it's going to be main scale reading plus circular scale reading. You know the main scale reading, and yeah, what do I mean by 0 is this is the 0. I think that will appear. Sometimes there will be errors, but try to understand this is the 0. Okay, but that is practically speaking, not in exams, right? That will be in your labs, the first year. That's it. Okay. So this is going to be your measurement. Your measurement is main scale reading plus circular scale reading. What is circular scale reading? Least count into the coinciding main scale circular scale division on the main scale baseline or reference line. Right? That is it. Let's do a sample problem again. So generally given like this is 1, this is 2. That means the pitch is 0.5 even in this case, and which division is coinciding. So what is your main scale reading? The main scale reading is going to be 2.5. Is that what it is? This is 2.5. This is 1. This is 2. How much is this? This is going to be 2.5 mm. Okay, again this is in mm. Sometimes this can be in generally in mm only. Okay, this is 2.5 mm. Which is the coinciding division? This is 39. How about this? This is 38. Coinciding division or the circular scale division coinciding with the baseline is 38 or 38, whatever you like to call it, 38. Okay, go this way if this is nearby, go this way if this is nearby. Okay, generally, so this will be like 37, 36, yes. And what is the least count? So let's say 50 divisions are there. Here everything is not told to you. So let's say 50 divisions are there. Then what is the value of your least count? How do you do that? So this is first things that you need to notice. I like to move from circular scale reading to main scale reading generally, okay? Because circular scale reading is the one that is more exhausting, right? So your least count is pitch divided by number of circular scale division and it hasn't been told to you how many are that, but I'm telling you now it is 50. Okay, and you know the value of pitch. If this is 1, how much is a pitch? 0.5 mm. 0.5 mm divided by 50, again 10 to the power minus 2, 0.01 mm. What is your circular scale reading then? It is nothing but coinciding circular scale division with baseline or reference line multiplied with least count. How much is that? That is 38th division was coinciding, isn't it? I think I'll write it down over here. So your 38th division was coinciding, if you remember it. And what is your least count? 0.01 mm. How much does that give you? 0.38 mm. Half a day of practice will complete your screw gauge and vernier calipers, and you can expect a question in 1 or 2 years in your JEE Mains and your JEE Advanced once in 3 years at least. What about your main scale reading? That is 2.5 mm. Okay, I'm a circular scale reading. My circular scale reading is how much? 0.38 mm. And what about your main scale reading? Main scale reading is 2.5 mm. You can also again read it if you want. Get accustomed to diagram based question, guys. Okay, so your measurement is how much? Actually, with this we have completed not all the concepts required for JEE Advanced and JEE Mains, but we have completed the main concepts of your vernier screw gauge. Okay, so it's going to be 0.38 plus 2.5, but your questions will include zero error and error analysis. That's why since the beginning I've been telling you complete the error analysis as well. So it's going to be 2.8 mm. Right, your reading should be 2.88 mm. Right? So let's move on and get started initially with a very small problem, and then we'll move into a JEE Advanced and JEE Mains problem. JEE Advanced problem was also given and on the same concept, but little bit twisted here and there. One was with error analysis that we'll deal at the end. Okay, since I'm assuming some of you might have not covered error analysis, but do complete it, guys. Screw gauge, error analysis, and your complete everything, even dimension analysis. That is also very important. You often get from this units and dimensions or units and measurements, you definitely get like one or other question. Significant figures, all these lectures you have to complete it, guys. With this lecture, we are going to end units and measurements. We'll be getting started with some DPPs and PYQs from the next week, but make sure you are completing everything. Okay, so it's an interesting question. 5 complete rotations of the screw gauge causes it to move. This is true though, okay? Move at a linear distance of 0.25 mm. There are 100 circular scale divisions. Okay, the thickness of the wire measured by the screw gauge gives a reading of 4 main scale division and 30 circular scale division. Pretty easy. 4 main scale division. 4 main scale division means 4 times pitch. We need to first of all find out how much is our pitch. Okay, so our pitch is how much in this case? Pitch is equal to main scale division is equal to how much? 5 complete rotations gave me a linear movement of 0.25 mm. How much is that? 0.05 mm. Is that what your pitch is? Right? How about a number of circular scale divisions? So what do I mean by number of circular scale divisions? So number of one circular scale can have this many amount of quantified amount of divisions on it. So there are 100 equally calibrated circular scale divisions. It's equally calibrated since the measuring instrument. How much should be your least count be? That small momentum that is going to give you the pitch or 1 MSD divided by 100, in this case number of circular scale division. Head scale division, circular scale division. How much is that? I don't want to actually calculate this, I'm just going to keep it as 0.05 by 100. I'll tell you the reason. So I like to do this even in my error analysis. I'll tell you why. And that being said, you have your reading gives you 4 main scale divisions. That means what is your MSR? Your MSR is nothing but MSD, 1 MSD into 4. How much is that? That is going to be 4 into 0.05. That is 0.2. 0.20, you will write it as 0.20. And yes, 0.20. So your MSR is 0.20 mm. Remember this. Okay. How do you do this? Every type of problem is what I have tried to touch in this like class. What is your circular scale reading? Your circular scale reading is nothing but a least count into the coinciding thing. This time I'm going to write it down as coinciding, just coinciding circular scale division, something like that. So writing down CDF. Okay, just try to understand that. And how much is your least count? Your least count is something like 0.05. That's what you have divided by 100. We kept it just like that for a reason, into 30. Okay, so how much is this? Very accurate device, huh? Actually, there would be even a 0 over here if you have noticed it. Actually, there would be a 0 over here, right? That is the level of accuracy of this, measuring instrument. This is your circular scale reading. Okay. And guys, what do you need to do now? Your measurement. Your measurement. Let's move on to the next page. If you have we don't have another page. What is your measurement? Your measurement is circular scale reading plus main scale reading. Your measurement circular scale reading plus main scale reading. How much does that give you? 0.20 plus 0.0150 mm. So what is the value of your measurement or your reading? 0. Quite easy, 215 mm. Okay. You did it. 0.215. Sorry, this was all in centimeters, I guess. I'm sorry, guys. So this was all in centimeters. But anyway, you understood, right? So be careful about the units. But what we did is we mistook, for centimeters mm. But your units can be interchanged even over there. So make sure you are getting everything correct. Okay. This was all in centimeters that we measured. If you had converted it to mm, it could have been easy. And your answers can be in mm. Okay, this can be given in centimeters. In this case, it's given in centimeters, but it can be also given in mm. Okay, so make sure you're not making that mistake, like what we did over here. Okay, that is it. So it's a JEE Advanced problem. Do you think there is anything there in this problem? I'm not sure if anything is there in this problem. Maybe there is something. The JEE Advanced problem, so be careful generally. Okay. There can be easy problems. I'm not saying the JEE Advanced won't have, non-confusing or easy problems. There can be, but always be careful. Why not be, careful about the things? So, what is being told to you? Screw gauge gives you the reading when you try to measure the diameter of the wire. One is, like main scale reading is 0 mm and circular scale reading is 52 divisions. right? Okay, and given that 1 mm on main scale corresponds to 100 divisions on the circular scale. I told you one rotation corresponds to one pitch. Here they have given you 1 mm. They haven't told you what is pitch, what is your least count, etc., etc. They have just told you 1 mm corresponds to 100 divisions on circular scale. Then what is the diameter of the wire from this data? Okay, so what is the value of your one circular scale division or one least count? How much is that? I mean, real least count, right? Like in this case, I would rather not take it as okay. This is only the the least count that you can measure, the circular scale division. And what is the value of that? 1 mm divided by 100. And what was your reading? Your circular scale reading is 52 divided by 100. That is an mm. That is going to give you 0.52 mm. Isn't it? Yes. And since main scale reading is 0, what should be a reading be? Pretty straightforward, right? Easy. I told you easy questions is what you will get. How much is that? 0.52 mm. Right? But answer is given in centimeter. So what did we get? 0.52 mm. And that converted to centimeter should give you 0.052 centimeter. I think this must have been 0.05 or this must have been 0.052. I think I just miscopied it. This should be the answer. Okay. I think I did miscopy it. Maybe. Okay. Yeah, I'm sure. Okay. So that is giving you answers. I mean, like everything is given in mm. Answer is being asked in centimeters. So that is where the JEE played the trick. JEE Advanced played the trick. That's it. Try to grasp the trick that has been played on you in each of the question. 52nd division, straightforward question. Okay, I got the answer as 0.52 mm. If I see a 0.52 mm, I would have marked it, but it was asked in centimeters. So you move another decimal to the left. I mean, like it has 0 after the decimal point. So it's going to be 0.052 centimeter. Right? Let's move to another JEE Advanced problem. This is an easy one, guys. So that's what I told you. It involves significant figures and analysis. Combination is what you will get. The pitch of a screw gauge is 1 mm and there are 100 divisions on the circular scale. While measuring the diameter of the wire, the linear scale reads 1 mm and the 47 division on the circular scale coincides with the reference line baseline. Okay, coincides with the reference line. The length of the wire is 5.6 centimeter. Find the curved surface area in centimeter into centimeter square of the wire in appropriate number of significant figures. Significant figures, you must understood how to do this. Let's get started with this, okay? Then you'll understand about significant figures. That is fine if you don't know the concept yet. First of all, it's a challenge of calculating what your least count. There is no challenge in that. It is basically pitch divided by number of CSDs. And how much is that? 1 divided by 100 mm. 47 division was coinciding. with the reference line. So what is the circular scale reading? 47 into least count. How much is that? 47 divided by 100. 0.47 mm. Okay, it's all in mm. We need to convert it into centimeter. Okay, and we'll do that only at the end. Do remember that. Okay, do entire calculation and then you will convert it into the significant figure. So until your reading is actually accurate. Maybe one of the reading is not that accurate. Okay, and what is your main scale reading? It reads 1 mm, straight away given to you. So this is your MSR. I need not say you know that. See how simple is this problem. This is your JEE Advanced problem. Even the earlier one you saw was really simple. Just mm to centimeter conversion. Measurement is equal to MSR plus CSR, and your MSR is 1 mm given to you, and your CSR is 0.47 mm. How much are you getting it? 1.47 mm. This is a measurement of what are you measuring actually now? The diameter of the wire is what you are measuring. Do remember that. Hi. You are measuring the diameter. Okay. So we are measuring diameter. Is that what we are measuring? Yes. Okay, now don't take it for radius, then things will mess up. Okay, and your what is asked now, you know, 1.47 mm. You'll convert it into centimeter, guys. Basically you'll try and convert this into centimeter before your calculation, but it is fine even if you don't. You can calculate everything in mm and then give out the answer in centimeter square, but rounding off should be on that significant square. I mean, like significant figure. Okay, 0.147 centimeter. Okay. Madhuri, actually no, because the thing is, this is a JEE English channel, so I'm supposed to speak in English. Maybe we'll do some sessions on Unacademy Learning app as well as in Hindi, don't worry about it, but try to even grasp the terminologies that we're discussing over here, because you know there are many problems which only involves complicated language, and the answer lies in the question itself. Okay. So that is one of the things you should get accustomed to over the time if you are giving it in, you know, English. Okay, your paper medium is in English. So what is being asked? Curved surface area. Notice it. They are asking you curved surface area. If there is a wire, what is the curved surface area? Curved surface area is going to be not that, you know. This is going to be a curved surface area. What is that? That is going to be 2 pi r L. Is that what it is? I can write it down as pi dl. We calculate it in diameter, but we can do this. Okay, and okay, given to you all the things, and they're asking you find the curved surface area. Okay, it's a simple one then. Thought there was more in it. So what is your area? Area is going to be pi dl, which is 0.22 by 7 is what pi is, and this 0.147 into, you have a length of 5.6, and okay, just a moment. This goes by 7. How much do you have? This should give you 0.8, I guess. All right. So what is your area right now? Your area is something like this, all in centimeter square, right? This is in centimeter and this is also in centimeter. This is 0.147 centimeter if you remember. Okay. Madhuri, try to grasp it in English because that's going to be useful for your exam. And this gives you 2.58 2.58. Is that what it is? 2.58 something, but I'm not going to do beyond it. You know why? There will be more in this. I have to round it off to the appropriate number of significant figures. Which is the value with the least significant figure, the length of the wire. So your accuracy cannot be more than the number of significant figures that is present in the length of the wire. So you round off your area to 2.6 centimeters square. That's it. Understood? There in addition and subtraction it was, least decimal place. Here it is about, once you can do the calculation, if it goes wrong, you can check it out. But this is how you do it, okay? Because there's also 2.8 given to you. I believe it is 2.58. Yeah. Okay, let's move on to the next question. Next important topic in this. It is going to be Hi Lion Flame Official. Hi. Awesome name. So we are going to talk about something awesome. That is going to be about zero error, one of the most shouted out and asked topics in JEE Advanced and JEE Mains also. Okay. Vernier calipers can just come like that without zero errors, but definitely your, screw gauge comes with all the kind of zero errors. And even in a lab, you will see that your screw gauge comes with all the kind of zero errors. Okay. What is a zero error basically? So in this, until now, we haven't discussed something. Your zero of the circular scale should coincide with the zero of the main scale or the baseline. Sorry. Okay. It has to basically coincide with the zero of the baseline or the reference line. If it all does not do, it arises an error in one direction known as zero error. It's a systematic error. Okay. If at all the baseline and zero does not coincide, what is happening? Try to imagine it. Let's take up a case. Okay. So there can be two kinds of zero error. One is going to be a negative zero error. The other one is going to be a positive zero error. Okay, there are two kinds of zero error. One is negative zero error and the other one is positive zero error. Let's take up a case and understand it. Okay, now we are actually dealing with negative zero error. Okay, once you have started, you have noticed that your like zero is not coinciding with the baseline. Zero is somewhere over here. This is the baseline and this is your zero on circular scale. So what is going wrong? Now every time you are going to rotate and measure, you are actually measuring something less. You are rotating it in anti-clockwise. Think about it. You are rotating it in anti-clockwise. It will pass through 0 and come back again to some other value. Let it be even 48 again. But you have missed around that, this is 46th division. You have actually missed, 4 divisions. So in a negative zero error, this case was actually about, like a positive and negative, both has been simulated in this case. What you are doing is you are missing that, that 0 point, like whatever, like 4 into that least count. Okay. So basically you need to add that to get the accurate value, because think about it, you're measuring, what is happening? You are missing out that 4 readings. You're rotating it in anti-clockwise. 0 comes through like this. Once you start rotating, 0 will come down like this. And it requires 4 divisions, this 4 divisions right now to achieve that, 0 value. So that means you're actually measuring that, 4 into least count, but you haven't included that 4 into least count in your reading it. So you would have to include that 4 into 0 least count. Okay. So the thing is, in your questions they will say your 0 lies above the baseline, actually not below the baseline. I guess it should be above the baseline. Okay. So it should be above the baseline. Okay, so your 0 will lie above the baseline. So that is known as negative 0 error. And what would you do? You basically calculate, it will be told as negative 0 error, will be given in the exam as -3, -4, if you notice it in your JEE advanced exam. But you would have to add it, guys, you need to add it. Okay, so it's basically least count into coinciding, that circular scale division before the correction, that is before you rotate it. So in this case it's going to be coinciding division is how much? -4. You'll add this 4 to your value. Okay, you're not going to do 46. 46 is a false way of doing it. Okay, people often talk about that, but if you do that, you'll get a false reading, especially negative 0 error is where things go wrong. Soon, line flame, yeah. So try to understand this point. You'd have to add that 4 values. Try to adjust it with 4 values while you're doing it. That is about negative 0 error. You'll add negative 0 error to your measurement. And what about positive 0 error? Your 0 lies below the baseline. I guess there is an issue. Yeah, this is correct. Yeah, your 0 lies below the baseline. Okay, now think about it. You're rotating it in anti-clockwise direction. Now always you're measuring some extra value. You're measuring that extra value. This is, oh god, this should be positive 0 error. Okay, this should be not negative but positive 0 error. Okay, this is positive. Okay, this should also be positive 0 error. I think there is some typing issue, that's why both the places you have things mixed up. But notice the diagram, that will tell you, and try to understand things intuitively. You will understand things. Okay, so this 0 where it is lying lying below the scale. It is somewhere at 4 reading depending upon this screw gauge. And now you're always measuring 4 units more and more and more. So what will you do? You will subtract it. You will subtract it from your reading. Positive error will be subtracted, be it this is positive, so positive error will be subtracted from your reading, be it your be it your Vernier calipers or your screw gauge. You will subtract positive 0 error and you will add negative 0 error. Alright, let's move into this problem. This is a JEE advanced problem. Look at this problem. It's super simple, guys. There are 2 figures given to you, and this is literally count the, find out the reading. That's it, including the 0 error. This was a 4 marks question. Okay, in a screw gauge, the 0 of the main scale coincides with the 5th division of the circular scale, like this. You see, 0 lies below. Okay, that's what it should be. 0 lies below. Okay, that was written wrong, just correct it. So now it is coinciding with the 5th division. This is at 0 value. Okay, now the thing is, what you need to do, you need to look at the next picture. So the next picture, they are telling you that the diameter of the ball given to you, you should find out the diameter of the ball from this picture. That's it. So I told you, get accustomed to reading the pictures. Okay, yeah, that is it. Okay, so you got your value of 0 error. So I'll tell you some trick to do this problem. You don't have to spend a lot of time. You remember, positive 0 error should be subtracted. Don't go through the hassle of doing everything. Let me tell you something easy. Okay, what are the number of circular scale division on your screw gauge? 50, and 0.5 mm is what it is on the main scale in one rotation. One rotation gives you 0.5 mm. Okay, one rotation gives you 0.5 mm. Let's get started with the problem. First of all, let's count the least count. Least count is equal to pitch, which is nothing but moves, one thread or one MSD or one movement, whatever it is, MSD, you can call it as MSD, etc., divided by number of circular scale division. Okay, I'll do it. I'll just write it down neatly, but you understood how to do this problem. This is a very easy problem, right? This is how you get your problems, guys. That is why screw gauge and vernier calipers you should cover. Okay, 1 MSD or something like that. By number of circular scale divisions. How much is that giving you? 0.5 mm is what it is, and 50 on the denominator. That's going to be 10 to the power minus 2. That's what I told you. This is one of the ways of doing it. 10 to the power minus 2 mm. And your least count is 10 to the power minus 2 mm, or you can write it down as 0.01 mm. 10 to the power minus 2 because it's very convenient to think in terms of 10 to the power minus 2 while calculating it, while dividing it. Okay, that is the reason. And now let's do the reading, guys. How much is this? 0.5. How much is this? 1. Okay, they haven't told you it is 1 mm. Okay, the screw gauge given, the 0 of the main scale coincides with the 5th division of the circular scale in the given diagram, and the circular scale division of screw gauge is of 50 and it moves 0.5 mm. You have to read the second one to understand the diameter of this ball. This ball is over here, right? This ball is over here. You need to understand the diameter of this ball. It is 1 mm. That's it. Main scale reading is 1 mm. One of the ways of doing this is you calculate MSR plus CSR, and what is the coinciding division? 25. That is also given to you. One of the ways of doing it is going by MSR and CSR and doing it. Other way of doing it is, okay, let's do the traditional method and I'll talk about the easier method. So what should be a CSR? The CSR should be least count into 25, because 25th division is what is coinciding. So that's not a huge trick though, anyway. So this is going to be 1 divided by 100, or 0.01 mm is what it was. So it should be 25, and your CSR should be 0.125. Sorry, 0.25. I'm really very sorry, guys. 0.25. Okay. 0.25 is what it is. Now think about it. What you need to do, this is your reading. Reading is not just MSR plus CSR anymore. It's MSR plus CSR minus the correction. Okay. The positive error. This is a positive error. Positive error you will subtract. How much is a positive error? A positive error was something like 5th division is what it is coinciding initially even at a 0 reading. Okay, that is 5th into the least count. How much does that give you? That gives you 0.05 mm. Okay. How much is measurement? Measurement is going to be CSR plus MSR minus of positive error. Right? That is what it should be. How much is CSR plus MSR is going to give you? I believe this is 0.25 and this is 1 mm. Is that what it is? Yes, that is what it is. Okay. And this is 0.05. How much does that give you? 1.20 mm. Okay, this is a little lengthier way of doing it. If you have seen the number of steps, that is a lot. Okay, let me tell you something interesting that can be done. Even I could have formulated something around that, but I didn't do it. So I'm going to write it down as reading. Okay, so it should be option C. Right, they are given intentionally 2.5, etc. Okay, now let me tell you something. So if at all, one of the things I can do is just understand that it was not 25 division rotation, let me come to this picture. I'm going to erase everything, guys. You can note it down. I'm going to erase everything. Just try to focus now, okay? So initially it was already at the 5th division, not at 0. Now it is at 25th division. How many rotations, how many divisions it has actually moved? Only 25 minus 5. 20. Could we directly do it as something like, reading is equal to MSR plus 20 into least count. MSR, we saw 1 mm plus 20, we just calculate all that least counting. You have to calculate the least count. Basically, even over here you can write it down, 1 by 100. How much does that give you? 1.2 mm. It could have been this much faster. If you understood the concept, it could be this faster. That's why I was stressing so much on the concept. Right? Let's have a look at another JEE Advanced problem. Okay. Now I guess this is also a cakewalk. Notice it. 2 full turns of a circular scale of screw gauge covers 1 mm. 2 full turns, 2 rotations. Okay, the total number of divisions on the circular scale is 50 divisions, 50 calibrations on the circular scale. Furthermore, it is found that the screw gauge has a zero error of minus 0.3 mm. Minus 0.3 means it is freaking negative error. You will add this 0.03, minus 0.03 mm. Okay, while the student while measuring the diameter of a thin wire, a student notes that the main scale reading is at 3 mm. Okay, and the number of circular scale divisions in line with the main scale is 35. Okay, basically it's coinciding with the reference line. Okay, that is what it is. In line, etc. It's a little complicated language, but anyway. So diameter of the wires. Quickly, guys, you need to add that 0.03. First of all, least count. How much is it? This time I'm directly writing it down. Okay, it is 50 total number of divisions. 1 mm after 2 turns. That means your main scale division is actually 1 by 2. Okay, this is what your main scale division is, or your pitch is, and divided by how much? 50 is what it is. This is your number of circular scale divisions. How much does that give you? Least count is equal to 1 by 100 of an mm. Now 3 mm into 35. Okay, so your reading is going to be how much? 3 mm. Since main scale reading is directly given to you, you would not go through the hassle of doing everything. MSR plus CSR, and MSR plus CSR, it's least count into the coinciding division 35. But one thing you understood over here is you have to add the 0.03. You can do it like this as well, or just add 3 to this. If you have already understood it's 0.01 mm or this 0.03 mm, you could have added it straight away. How much does that give you? 3.38 mm. Is that what it is? Yes. Let's check out whether our answer is correct. Yes, our answer is correct. Quite easy, quite easy, quite easy, quite easy. Let's do one more problem of this kind, and then we'll move into a JEE Advanced problem again, because this kind of terminologies can also be used. So this chapter, you noticed a lot of terminology based things, guys. Okay, a lot of terminology. Head scale, who cares? I mean, you could have named it just as like circular scale, but people do use different names. So yes, so the pitch of a screw gauge having 50 divisions on its circular scale is 1 mm. So pitch is directly given to you as 1 mm, and it has 50 divisions. You already understood that the least count is 1 by 50. When 2 jaws of the screw gauge are in contact, the zero of the circular scale lies 6 divisions below the line of graduation. When a wire is placed between the jaws, 3 linear scale divisions are clearly visible, while the 31st division of the circular scale coincides. Okay, while the 31st division of the circular scale coincides. You're going to rotate it in anti-clockwise. Right? If your 0 already lies 6 divisions below the below the graduation line, that means it is already reading some positive value which you have to actually subtract. I hope you understood that point. Let's move on and calculate it. Least count is equal to how much? It is 1 mm is the pitch. Is the pitch, and how many number of divisions? 50 divisions. Okay, circular scale divisions. Okay, so least count, I'm just going to leave it like that as usual, 1 by 50. I like to do that. And what about your main scale reading? Your main scale reading, 3 linear scale readings are clearly visible. Okay, 3 linear scale reading are clearly visible. Then my main scale reading is 1 mm only. And the main scale reading is 3 into 1 mm. That is 3 mm only. Okay. Now the thing is, you must be skeptical whether I need to add or subtract. I'll take you back to that concept. Okay. Just for 2 seconds, let's go back there and understand when they are talking about below and above. Where is 0 lying? Below. Positive reading? Subtract. Negative error? 0 is above. You're rotating it in anti-clockwise direction. So you're measuring something extra all the time. Okay. So what should have been your actual, I'm going to do this time this way, actual circular scale reading is that, I'm directly writing it down. 31 minus 6, since 0 is like 6 divisions below, you're already reading some positive value. 31 minus 6 into least count is what it is. 1 by 50 is the least count. It is 25 by 50. Point 5 is what you are getting. 1 by 2 of an mm, 0.5 mm. So this is your actual CSR. So what is your reading or measurement? Your measurement is going to be MSR plus CSR, actual CSR. CSR corrected or CSR actual, whatever you like to call it. However you like to call it. It's actually 0.50 anyway. Get into the habit of writing it down like that. And it's 0.50 and this is going to be 3.50 mm only. So that's not 5.6, don't mistake me, it's 5.0. If it looks like 6, that's a great mistake. Okay, right? So both the options are given to you just to confuse you. 3.74 and 3.50. All right, let's move into a JEE Mains question before moving into the JEE Advanced question. So given to you is a screw gauge with a pitch of 0.5 mm and a circular scale divisions of 50. Your least count is how much? Pitch divided by 50. How much is the pitch? 0.5 divided by 50. this is, like how much? 0.01. Okay, let's do that anyway. Before starting the measurement, it was found that when the two jaws of the screw, again you see the two jaws of the screw are brought in contact, the 45th division coincides with the main scale, and that the zero of the main scale is barely visible. This is being told because even Vernier calipers, sometimes this will be given. If this is not given, if they're saying one division is clearly visible, means already you have a zero error of 1. Do remember that point. Do remember that. Even a negative error, what you'll do is you'll actually rotate it to see, once I reach 0, 0 is visible. 0 on circular scale, then 0 on your main scale should be visible. Even that is applicable for Vernier calipers. Okay. What is the thickness? Else you'll add that main scale reading as well, because that's an error. If it's a negative error, you'll add it. If it's a positive error, you'll subtract. And what is the thickness of the sheet if the main scale reading is 0.5 mm and the 21st division coincides with the main scale line? Simple, guys. Simple. So here you're always measuring 5 divisions less. Right? Answer is straight away 0.7. If you are at the 45th division, then you're rotating to get to that 0 after 5 divisions. Okay, only 50 divisions are there. Think about it. Okay, little tricky, I guess. So let's do this. So what is the least count value? I'm directly writing it down. That is going to be pitch divided by number of circular scale division. How much is that? That is going to be 0.5 How much is the number of circular scale division? 50. Is that what it is? How much is the least count? 10 to the power minus 2. Now, let's come to the correction part. This you could have just try to do after some time try to do these things, just orally. Don't spend a lot of time doing the calculation. That's my honest suggestion to you. And now I need to understand something. What is the thickness of the sheet if my main scale reading is 0.5? MSR is 0.5. Okay, and 25th division coincides with the main scale. Only 45th division was visible. Sorry, it is sorry guys. So that should have been 0, not 0.7, but 0.8. I'm sorry. I'm really sorry. I think I noticed it in the wrong way. It should be 0.8. I'm really sorry. Yeah, I was thinking 5th division, but it was 45th division, or I don't know whether I said it in the wrong way. So 45th division was visible. That means you have to rotate 5 more divisions to reach the 25th division. So your actual CSR reading is nothing but 45. That means minus 5. Add that minus 5. That is going to be 30. 30 into least count. How much is your least count? 0.01, I guess. That is going to be 0.3 mm. And what is your main scale reading? MSR plus CSR is what it is, actual CSR or corrected CSR. If I told you, 45 gives you plus 5, that is correct. If it is minus 5, that is wrong. But minus 5, you are reading it in the beginning. 0.5 plus 0.3, how much is that? 0.8 mm. Okay, right away I said it as 0.70. That is wrong, guys. It is 0.8 mm. Because I think I thought it was 5th division in the mind. So let's move on to the next question. It was a pretty easy question, and guys, notice the kind of problems that you get in your JEE Mains and JEE Advanced. The simplest topic ever I have come across, but do remember, do cover the error analysis. It will come up also with stress and strain related problems. Okay, stress, strain, Young modulus, these kind of questions will also be asked. And notice this kind of question. It's a mixture of error analysis and this thing, screw gauge. Let's first understand the screw gauge side of it. So density of a solid ball is to be determined in an experiment, and the diameter of the ball is measured with a screw gauge whose pitch is 0.5 mm, and there are 50 divisions. We just did a similar one on the circular scale. 2.4%. I think that is correct. Oh, no. Do it again. Think you have missed out something. The reading on the main scale is 2.5 mm. Do it again. Do it. Put that pen on the paper. It's 20 divisions. The reading on the main scale is no, not B. Do it again. The reading on the main scale is 2.5 mm and that on the circular scale is 20 divisions. Okay. If the measured mass of the ball has a relative error of 2%, the percentage of error, what is relative error? Delta m by m into 100 is equal to 2%. Okay. That means delta m by m is 0.02. You know that. This is just one of the information that I'm giving you. So let's move forward and do it. So the what would be the percentage error in your density calculation? So no zero error actually in this case. 2.5 on your main scale. 20th circular division is matching. What is the value of your least count? Least count is nothing but pitch. This time I'm not going to write down. Okay, this is pitch. I'm just highlighting it. 0.5 mm. Okay, divided by 50 divisions. How much? Cancel it. 0.1 and then you have 10. That is going to be 10 to the power minus 2, which is nothing but 0.01 mm. So what is your circular scale reading? 20. So let's write it down. Reading is equal to circular scale reading plus main scale reading. Okay, or main scale reading plus circular scale reading. How much is it? 2.5 mm, not B. And do it again. Don't use calculator, students. Okay, these are like the questions that you're getting in JEE Advanced. Don't use calculator. And 20 into 0.01. What it should be? 2.7. Is that what it should be? 2.7 mm. This should be your reading. Right? Now, this is not the most important thing. Okay, this is important to further work on this problem, of course. You have to do the error analysis. But what is the most important thing over here? The significant figure. How wrong can this device go? How wrong can this measuring instrument go? As much as its least count, if you remember. I'm intentionally taking it up right now because people often forget this. This is the max error possible. Okay, let's do this. What we need to find out? Density error, mass by volume, which is nothing but mass divided by 4 by 3 pi r cube, which is nothing but d by 2 whole cube. Forget it, apply log and everything. What you will get it? Delta rho by rho is equal to delta m by m plus of this is whole cube, not square. If it appears as square, I'm sorry, and it should appear as a cube. Now it will appear as a cube. Okay, I guess there is some issue, and let's do this little slowly. I guess rho is equal to mass by volume. You found out the value of diameter. Okay, and what is the value of your mass? That you don't know. Anyway, what is the value of your volume? 4 by 3 pi r cube. It's a solid ball. 4 by 3 pi r cube, which is nothing but 4 by 3 d by 2 whole cube. All right, now let's get into the error analysis. What did you do? You take a log and take a differentiation, make negative as positive, because in error analysis you're calculating the maximum error possible in the row or density, whatever it is. It's density, right? Anyway, delta rho by rho is equal to delta m by m, and I already told you this. This is going to be, all these constants would move away. 3 into delta d by d. 3 into delta d by d is what you will get. Hope you understood this. 3 into delta d by d is what you would get, guys. Okay, 3 into delta d by d. You can check it out later how we did it, etc., etc. So now this is 0.022% can be written as 0.02. Now what about your 3 into least count divided by your measurement or your reading? That is what delta d by d is. How much is this? 0.02 plus of 2.70. Put that 0, and this is going to be 3 into, so that should be into a 3, and 0.01, and how much does that give you? I believe this is by 9, so this can be written as 0.9 as well. That is going to be how much? 0.02. We have an extra pages. Let's do this then. Okay, you need to do the math, guys. This is like a math problem and you need to do the math. A little bit of math problem, not really a math problem, but 0.02 plus of, I don't know, I think writing it down in the hurry spoils it. Let's go a little slowly. 0.02 plus of, how much this would be? Like 0.9, and you have just make it as 270 and make this as 1, then you're going to have it as 9t. Okay, near about 3% and odd. Okay, 1 by 100, think of it as 1 by 100, but it is not 3%, it is less than 3%, so this is not true, this is not true. Yeah, I think B is the correct answer. Yes, I'm sorry, I'm really sorry. Okay, your answer is correct, it should be B. Okay, that was my mistake. Okay, 20 divisions, 2.7, yes, it should be B. That is correct. Okay, it should be little less than, how much is that giving you? No. Wait a moment. I think it should be more than 2, right? Sorry, that should be C. Method of elimination is what you have to use. I'm sorry. It should be C. Okay, let me explain you how. 0.02 plus of 1 by 90. And how would you do this kind of problem? This is little greater than 0.1, so it's more than 3%. I'm sorry, it's not 2.4. I'm sorry, not 0.9%, not 4.2. It has not exceeded 2%. Okay, it should be C. You can calculate it and you'll get it as this one as 0.0. so in 100, how many is there? 1. Again, that would extend to 81, 90, 99, again 1, again there would be like a 1. It's 3.1. It's pretty clear actually. Okay, I'm really sorry. Okay, it should be C only. Okay, my estimate was fine. So yes, students, share the channel. Do not forget to share the channel and share the video. Like the video. Make sure you're liking the video and learning along with me. And guys, I come every day at 7:30. Make sure you are present here during the classes, especially 2022 aspirants. Don't be negligent, and 2021 aspirants, don't be negligent of the first year topics. You have super easy things like this, which can get you the marks that you want, and we are covering everything from the basics until advanced. So make sure you share this video and click on that subscribe button and bell notification. And that being said, guys, keep smiling, and you know what? You should ignore gossips now. Forget the gossips. And just keep smiling, ignore the gossips, and also students, work hard and smart to achieve your success and acquire knowledge and share it so that everyone can get access to quality content for the JEE preparation. And students, day after tomorrow, that is on Sunday at 6 p.m. we have a special class on what to do after your JEE Mains result. So what are you hoping for? What is your target? And whether what you're planning to get into IITs, NITs, or do you have a backup plan? Anything, be it, or you're going to give your JEE Advanced, be it, do attend this session. It's going to be a very short session. Possibly I'll try to keep it as short as possible. And that being said, students, download the Telegram app. If you don't have one, download the Telegram app. And guys, do get on to our Telegram channel. This is Unacademy's official JEE English channel, where you get all your updates on the classes happening on the JEE English channel, or the lecturers on JEE English on Unacademy Learning app on this channel. So download the Telegram app and click on to the link available in the description box below. Else you can just type in JEE_English to find us on Telegram. And that being said, guys, don't forget, JEE English is the nation's first channel where you get all your quality content from basics until advanced for your JEE preparation. And that being said, students, this Sunday from 11 a.m. to 2 p.m. we will have an awesome class on projectile motion. We'll cover every single concept required for your JEE Advanced and JEE Mains. So don't miss it out. We'll also discuss more model problems. It's going to be a special class. So don't miss it out, students. It's on Sunday, and that's going to be on Sunday from 11 a.m. to 2 p.m. It's going to be projectile motion in one shot, and everything that you need. It's an easy topic. I'll tell you how easy it is, be it on inclined plane, or be it on even on your normal plane or from a height. And guys, that being said, we have already covered electrical measuring instrumentation in one shot on 1st of September. Do check out this lecture. It's a very important lecture for your JEE Advanced and JEE Mains, and the topic is very straightforward and easy. Cover it, guys, cover it. Try to possibly cover everything around current electricity if you have 1 week, because it's one of the main topics in your JEE Advanced and your JEE Mains. Okay, be it your Advanced or Mains, you typically tend to get one question every 2 years or something like that. So check it out, and these classes are available on the Unacademy Learning app. For that, you need to download the Unacademy Learning app. All you need to do is type Unacademy on your Google Play Store and App Store, and then you'll click on that install button. And that being said, if you're looking for an awesome platform like a tutoring platform for your JEE preparation, like a complete package for JEE preparation, we have that comes with everything that you need for your JEE preparation, be it live test series, be it live quizzes. We have that. We have a systematic program for your JEE preparation. Everything that you need comes at an economical cost. And not only that, one subscription, unlimited access. All you need to do is click on to this extension bar, choose this first icon, and choose IIT JEE as your goal, and then you'll get your subscription. And that being said, students, it is not very expensive. It's economical. Apply Murlidharan coupon. Do not forget that you will get a 10% instant discount on your purchase. So do not forget to apply that, and your 24-month subscription is only going to cost you 2,100 per month. And that being said, apply Murlidharan coupon. Do not forget that you will get access to the best educators across the nation. Not only that, we have authors like DC Pandey sir on this platform. And guys, one more thing. is like you can also avail EMI option, and that EMI option is going to be a no cost EMI, so don't forget it. And you can also avail it through your debit card and credit card if necessary, or any UPI that you're comfortable with. And your 24-month subscription is the best one for your 11th and if you're 9th, 10th or 11th or your 11th preparation, this is going to be the thing that you want. And if you're in a long term or dropout, you may want to go for the 12-month subscription. So if you're in a long term or dropout, you may want to go for the 12-month subscription. And guys, that's also not very expensive. It's hardly 2,900. It's only 2,888. After you apply Murli Live coupon, do not forget to apply the Murli Live coupon. This is suitable only for long term and dropout, and you know that it's going to be a 2-year long journey. So don't miss out your 2-year long journey. Be focused, stay focused. Keep dreaming about keep dreaming about getting into IIT. Stay focused. That is all you need to do. Take care, stay safe, bye bye. See you in the next session. See you day after tomorrow at 11 a.m. and stay safe. Bye bye.